Hi everyone, my name is Leonardo and today I'm here to present our paper Self-Supervised Clustering based on Manifold Learning and Graph Convolutional Networks. So first for our motivation. The amount of digital data generated every day is constantly growing, and this huge amount of content creates an imperative demand for methods that are able to automatically organize, separate and obtain knowledge from data. Additionally, real-world scenarios often lack categorical information. By the many huge human efforts, these labeled sets are usually sparse, inaccurate, or even non-existent. In this scenario, community has explored other learning paradigms in order to solve this issue, such as the semi-supervised learning method, which uses a reduced set of labeled information, such as Graph Convolutional Networks, the unsupervised, exploring data relationship without labeled information, such as clustering and manifold learning, or the self-supervised, which combine other paradigms or learn by example. So, our main objective in this work is to exploit the experience of different learning paradigms based on the execution of a manifold learning algorithm to select a set of reliable soft label elements and use them to train a graph convolutional network. In this scenario, we aim to combine the unsupervised, semi-supervised, and self-supervised perspective into a single clustering technique. So, for our proposed approach, we have proposed the self-supervised graph convolutional clustering, which is a clustering method based on three main steps. In the first step, we get the input ranked list obtained from the features of the dataset and pass them through the log-based hypergraph of ranked references, which is a manifold learning algorithm based on hypergraphs. From this manifold learning algorithm, we get the hyperheads created by the algorithm, alongside with their weights, the improved set of ranked lists, and an improved KNN graph. In a second step, we get this output from the manifold learning methods and perform an initial clustering step. During this initial clustering step, we get an order of the elements based on the weights of the hyperedges, leader items that will direct all the agglomerations, and we created a set of soft labels which slices of the dataset, right? Reliable soft labels. Finally, we get the node features, the KNN graph, and the soft labels that we get on the last step, and we train a graph convolutional network in a semi-supervised manner. After training, this graph convolutional network is responsible for defining the final cluster configuration. So for our experimental results, we have evaluated our methods in 7 different scenarios, being 4 image datasets and 3 citation networks datasets. We also compared our approach with 6 classic and recent cluster methods, and we evaluated all methods with 3 evaluation metrics: the normalized multi-information, the v-measure, and the accuracy. For the image datasets, we can see that our models have obtained the best results in all metrics for all the 4 datasets, with large margins for a lot of the competitors' algorithms. We also can see that in citation networks, we have obtained the best results for Cora and CITSIR, and some comparable results in PubMed. Finally, for our conclusion, we have proposed a self-supervised clustering approach combining hypergraph-based manifold learning and GCN models. Our results are better in most of the evaluated scenarios, and as future work, we intend to further analyze parameter estimation, aiming for pre-select best values automatically. For more information, please check our complete paper, and the code is available in the link in the screen. Thanks.